this is the example of the result of the matrix calculation. So the minus value is the sequestration. This is just for the above ground example. And the plus is the net emission. And so that's just one layer on the above ground, but the other layer is the below ground on peat and mineral soil. So what we see here is for the three major islands of Indonesia, there is a little bit of decrease in the emission from the period of 1990 to 2000. But in the last 5 years, it's increased tremendously. And the number on the left-hand side of the bars, the 16% and 13%, the 13% is the contribution of peat oxidation of the newly developed plantation, while the 13% is the emission from the old plantation, because as the drainage is there, the soil keeps emitting this CO2. And the proportion is very high in the period of 2000 and 2005. This is because of the high proportion of the conversion of peatland. And in the period of 2005 and 2010, there is a high proportion of conversion of high biomass forests, especially in Kalimantan. That's why the increase is very significant. So by island, most of the emission from Kalimantan is from the biomass because of the conversion of disturbed forest, while in Sumatra, because of the existing oil palm plantation, plus the additional conversion of peat forests and whatever kind of peatland into agricultural, into oil palm plantation. So the emission, this is a comparison from of oil palm plantation compared to all land use change emission. In the first 5 years of the 2000, it's relatively low, but in the last 5 years, it's picking up. It shows the oil palm plantation is around 19%, and if you compare it, the area of oil palm plantation nationally is around 8 million hectares, but in these three islands it's around 7.7. So there is, compared to all land uses, it's significant, and there is a significant increase in the last 5 years. And this is what we have in our land cover reserve. It's again in the three major islands, and the disturbed forest is around 47 million hectares, and the undisturbed forest, so the disturbed forest is around 32 million hectares. And this may be the area that we should put aside because we still have the shrub, and the shrub is around 22, 23 million hectares. And whether the shrub from peat can be converted, whether it is safe. If it is mineral soil, we gain, in most cases, we gain carbon, so we sequestrate carbon. But the great question is whether you let the peat shrub as is, or you conserve it, or what. There are indications that the peat shrub, because of the influence of the drainage, so they emit CO2 anyway, and it doesn't contribute to the economy of the surrounding area. So it may be something that we need to study more, whether the emission from shrub is any higher than the emission from oil palm. So if not, we can prioritize, we can make use of the existing shrub, be it the on the mineral soil or the peat soil. So what we can conclude from this presentation is that most of the land converted to oil palm were relatively of low carbon stock, and also the conversion of other agricultural land. So the claim that more than 55% of the deforestation ends up in oil palm plantation cannot be proven here. And so the forest area, even though it's converted, but it's mostly the disturbed forest area. And the plantation on peat represent around 20% in Indonesia and around 13% in Malaysia. We don't have the figure yet for PNG, and maybe because the area is still very small, and we believe that it's still insignificant, if any. And land use change to oil palm in Indonesia in 2000 to 2005 is contributing to 7% of the total deforestation, and in the last 5 years it's increased dramatically. And other agricultural deforestation is due to agriculture and intensive logging. And usually when it is degraded, it's susceptible to fire. And the emission from land use change to oil palm in Indonesia, excluding fire, according to this estimate, is around 0.05 gigaton CO2. And this is around 9% of the 0.61 gigaton of total land use change emission. But in the last 5 years, it's increased to 19%, and the value is around 0.14 gigaton. And peat emission as a percent of the total oil palm emission, that's including all plantation, but it doesn't include the fire emission. It's very high in 2000 to 2005 because this is just percentage-wise, but the absolute value is not the same. The percentage-wise it's low because of a low percentage of the forest with or the initial land use with high biomass. So the main emission is from peat, the old plantation of on peatland and the new plantation. So our recommendation is that the future development should prioritize on low carbon stock land because the data very clearly shows. And the use of peatland should be a last resort. And in Indonesia, we have the term peat district because of the dominance of peat and peat provinces like Riau. Then the implementation of best management practice is imperative. And utilization of drainage-affected degraded peatland should be a priority, and we should study more on the environmental and economic consequences of this. And management of water tables in land banks and set-asides must contemplate on to the near natural forest condition. And land use planning in Papua, because it's going to pick up over there, it will be, should be a priority. And thank you very much for your attention.